It's kind of crazy.
The field would meet me and say, why would a physician scientist waste their career on the Human Genome Project?
I mean, why cannot everybody get a test?
Medical students will look back and say, without having a genome sequence of the patient in front of you, how prehistoric, how barbaric was that?
What keeps you up at night? Welcome everybody to The Sequence, Illumina's newest video podcast series where we bring you candid conversations between the people leading the genomics revolution. And my name is Cande Rogert. I'm very honored to be here today because I got the pleasure of hosting our Chief Medical Officer, a pioneer in genomics, Dr. Eric Green. Hello, Eric. Welcome to the podcast.
Oh, thanks so much. I'm delighted to be here.
I'm delighted to have you here today as well. So Eric, you worked in the public sector for many, many years, 3 decades, many years as the director of the NHGRI under the NIH. So let's go a little bit into your history. You come from a family of scientists?
Well, my father was a scientist. He was a PhD virologist, and all 3 of his kids became physicians, 2 of us MD PhDs. My sister was the middle child. She only got an MD, but that's what we always kid her about that. But yeah, all of us were physicians, 2 of us physician scientists.
So how did it click for you? What made you want to come into this field?
Just going into medical school and science. Well, maybe because by age 6, I was going in on weekends with my dad to the lab and seeing a lab and thinking it was pretty cool, even though it was just pipetting liquids and stuff like that. It was just, and that was a dinner time conversation, was excitement about science. And then I was imprinted by 2 older siblings who both decided to be pre-med, both went to medical school. So I just seemed to just follow the lead. I briefly thought about other careers. I just was really into research. And then ultimately with my MD PhD, I chose to do a more research oriented residency.
Cool.
It felt very natural, and it was by no means forced. And I have 2 children. My wife's, I married a physician. And I have 2 children, and one is a physician and one's starting medical school. And I think if you asked either of my 2 kids, they would say they didn't feel pressured at all. It just seemed like a natural thing to do.
I think it's like we grew up with. Like I was not in a family of scientists. My mom was a teacher and my dad worked for an airline company. But my husband is a scientist. And at dinner table, we've talked science every single day. So both my kids are very inclined to that. So either they're going to be detectives, which is fine, or one is a software engineer, and the other one, I don't know what it's going to be. But it's like cool to see that spark of curiosity coming into our children, right? Okay, Eric, let's go back for a bit, more than 25 years ago, when you started the Human Genome Project. It's a new field. Nobody's doing it. It's a government-funded project. Your advisor is encouraging you to go, but it's kind of crazy. You're putting your career out there to do something that may not be possible to do. Tell us a little bit the daunting aspect of it. How hard was it? Was everybody supportive of it, of the project, and of you actually going into that area? How was it?
Yeah, the truth is, even immediately before the Genome Project started, and all you had to do was look in the scientific journals to see editorials that were being written by some people who were against the Human Genome Project. And again, I think some people today sort of look at it and go, how could anybody be against the Human Genome Project? Because people just assumed it just happened. There was a pretty vocal minority. I don't think it was the majority, but people had concerns. It's really important to appreciate that everything about genomics, but certainly everything about the Human Genome Project was very different than the way biology had been pursued, biomedical research had been pursued, which traditionally done by individual labs, individual investigators. This was bringing a huge international consortium together, multiple disciplines, a lot of money, and doing something that some people didn't believe was a good idea. Their reasons for it, why they think it wasn't a good idea, some thought we should just sequence the parts that code for proteins, don't sequence the whole genome. That famous 4-letter word, junk, would be referred to as the majority of the human genome was junk. Why are we wasting time? We would never get it done because it was going to be too difficult. And they just didn't see the value. And so, and they felt threatened by having money diverted over, even though it was supposedly new money. They never believed that. And then the other class of criticism was a matter of who should do it. And I can tell you that headwind I got, some very prominent, well-meaning people, scientists, the field would meet me and say, why would a physician scientist waste their career on the Human Genome Project? As if it was such mindless work that was, not made for somebody with a medical degree, maybe not even with a PhD. I mean, like, this should be done by others, like hard labor kind of thing. So we have that headwind, and then you went for it, and then you had to face the fact that it wasn't going to be simple, and there were going to be lots of conflicting ideas on how to do it, and threats from the private sector, and concerns about funding, and then concerns about how are we ever going to make all this work, and will the technology be ready, and when should, the other big decision had to be, when were we ready to start sequencing, stop mapping the human genome, start sequencing. Yep. A lot of debate about that, because that revolutionary Illumina-like method, which everybody thought would come within a handful of years into the Human Genome Project, didn't come until after the Human Genome Project. And so we eventually did it with the incremental but important improvements to the classic method developed by Fred Sanger. And that's what got us across. So, there was so much doubt for so long, and so many things that came along the way. But once you started to see some of the success, and then you saw that this might be possible, it just made people go harder, faster.
But for all those younger people that are maybe in school right now, or they became scientists very recently, how was it to work during the Human Genome Project? What were the things the challenges that you had as a scientist or as a leader? What were the highlights, you would say?
I spend a lot of time talking to trainees. I still have that as a regular part of any routine when I visit a university. I always want to talk to the trainees. I love talking to students. I love lecturing to students. And one of the common things I'm seeing, first of all, they think genomics has been around forever, which it's not. It's still a young discipline. The field only came into being in 1987. There were no genomicists when the Human Genome Project began. I mean, nobody was trained in genomics because the field had just started. The field of genomics and the individuals who came together to pursue the Human Genome Project, we were just a bunch of human geneticists, a medical geneticist, a biologist. I was a cell biologist. I was training as a pathologist. But when we got to that starting line of the Human Genome Project, you looked around and there were physicists, and there were chemists and computational biologists, and sociologists and philosophers and bioethicists, and it was amazing, and engineers, of course. And it was this confluence of people all bringing different skills, different capabilities, but taking on a challenge that we didn't really know how we were going to achieve it, actually read out the complete human genome sequence. And yet these incredibly motivated, talented, highly collaborative people came from multiple countries and just went for it.
And I'm a firm believer that the main breakthroughs in science happen at the interface of disciplines, right? Do you
100%.
think that had a lot to do with the success of the Human Project?
Yeah, no, it absolutely was critical. It was a critical element, because any one discipline only could bring together a piece of the puzzle. And it was very clear that yes, it seemed appropriate in 1990 to start the Human Genome Project, but the fundamental tools we had, and remember, that was in the absence of much of a functional internet or anything that we think of as data science or bioinformatics today. It was in some ways, that's the audacity that we actually thought we could. And it required a complete re-engineering of the fundamental chemistry and biochemistry that went in at the most simplified level of how we would sequence DNA, but then get it to the point where it could scale up to be able to read out 3 billion letters of the human genome.
Yeah. So we had a private sector going for the human genome and a public sector doing it. Do you think that having this merge of fields, of people, of countries, of private and public helped get us to where we were? And how important has that been for the world, basically?
Well, the thing I would immediately point out is that even before the Genome Project had a private sector entity directly competing with it, even before that, there were a number of private sector endeavors that were popping up to try to capitalize on the various opportunities in the young field of genomics. And then if you fast forward to today, the same thing exists. I mean, there's a lot of public efforts, there's a lot of private efforts. So I think that's all part of this ecosystem that I referred to at the very beginning. I mean, there is this ecosystem of academia and government and private sector. And sometimes they're collaborating, and sometimes they're friendly competing, and sometimes maybe they're not even so friendly competing. So I've sort of just gotten used to that. It's all just part of the real world. To directly address your question, there's without a doubt, the Genome Project got done faster because there was a direct competitive threat by a private entity that basically wanted the Human Genome Project to stop and let them go on. And I think that's what resulted in the US Congress providing more funds, the Wellcome Trust providing more funds, and they just said, go faster. And so the Human Genome Project did, and we ended up finishing in 13 years when originally it was envisioned as taking 15 years.
Awesome, because without it, we couldn't have
What's
many of
happened?
the
And it just meant
technologies that we have today, right?
Just meant we got on with
Yeah,
with the
exactly.
next part of this great journey of genomics.
Yes, absolutely. So way back then, when the human genome was a dream, what brought you to genomics? What inspired you to come over to this field and leave the traditional cell biology side of things to come into this interdiscipline of technology development?
I mean, a lot of it was fortuitous and a lot of it was luck. I mean, I think there's a lot of these things in our lives, in our personal and professional journeys, that you can't say you had this grand plan, it all just worked out perfectly. I was at the right place at the right time. I was at Washington University. I had decided not to do a clinically intensive residency, a very clinically light residency of pathology, and just the half of pathology that is running the diagnostic laboratories in hospitals. So residence also known as lab medicine. That did inoculate me at this idea of, diagnostics and, high throughput machinery. And so there's a whole mentality that now has come full circle in genomics. But I would also say that there was so much excitement at WashU around genomics. There were some real pioneers and real the architects of the Human Genome Project, a couple of them in particular, were at Washington University at the time. And I have to admit, I never purified DNA. I could barely spell DNA. I had pursued something completely different for graduate school, but it just seemed cool. And it just seemed like maybe this would be a good marriage of my clinical interests. So I was a physician, and that's part of what I brought to the table. I was a pathologist, brought that. I guess I had some biochemistry and cell biology credentials, so that was my persona. And I figured I would be taught all the rest. But it was just so exciting. And then just one thing led to the other because, 2 years into my postdoctoral fellowship, here we were writing one of the first grants for the Human Genome Project, got one of the first centers, and off we went to map and sequence the human genome. So there was no grand plan. It just one thing led to another. I had an outstanding postdoctoral mentor, Maynard Olson, who firmly believed that, put your trainee in the right place and then shove them to the front line and make them do it all. So, there I was as a postdoc running a program on the Human Genome Project. It's because of the generosity of my mentor that gave me that opportunity. But I took full advantage of it, hired people, kept going and said, this is awesome. And there was this sense of, this is historic. This is like, you're not going to have multiple shots at being involved in something like that.
That way?
I
You really felt it? That's awesome.
No, you really felt it. No, I think I can speak for that generation of genomicists who were either postdocs or were just, junior scientists, maybe even early assistant professors. And there was a cadre of us that I think if you talk to most of us, there was that sense of this is so unusual and this is now. When during the rough times of the Human Genome Project, and I think people should appreciate, there were rough times. It wasn't always obvious every single day this was going to work, this was going to be successful, that we were going to get across the finish line. Then we were nervous because I think we felt more vulnerable being more junior scientists. This was our career. We were all in. All of our chips were in on making a career of this. Good news is it all worked out pretty well.
It is awesome to see how many of us end up where we are because a little bit of ingenuity and just go for it. And it's here, let's take the opportunity and move, right?
You come to a fork in the road and I'm going right, you know, and then you don't crawl across, you sprint because in this case, because it just seems so exciting.
Yeah. So you start and you're working on it and you have all these people pushing against you. And yes, getting the letters was important, but what pushed the vision? What helped you see that vision of what you could do with the letters? Right? Because we knew a little bit about genomics at that time, maybe quite a bit, but there was still a lot unknown. So,
but if I go back to the day the Human Genome Project ended, you know, I got to be really candid. You know, here I got to be one of the people waving the physician flag of, oh, you know, we did this because now we have the human blueprint. We will improve the practice of medicine. I'm really convinced if you would have interviewed me in April of 2003 and you would have said, and we will be changing how we treat and manage cancer while you're still alive, I probably would have said, oh, wait a second, hold on. You know, I really did not have the conceptualization when the Genome Project ended that medicine would change in my lifetime. I really didn't. And probably the reason, which seems really relevant now that I'm at Illumina, was the cost. I mean, we had finished the Human Genome Project, but you know, that first human genome sequence did cost $1 billion. And I knew enough about clinical medicine to know that $1 billion was too expensive for a test for a patient. And, you know, and in April of 2003, how we were going to get it from $1 billion down to less than 1,000, even though that's what we said we should do. But I don't think we had any idea that it would happen in anything measured in other than several decades. But it didn't take that long. You know, and then all of a sudden when the new technologies come on board, you start being able to reduce it. Then, well, what the heck? Let's start sequencing cancer specimens. Hey, what the heck? Let's start sequencing a patient with an undiagnosed clinical condition. You know, then you just start to see these examples. But for me to say here, oh, I knew when it was going to happen, that would be the biggest revisionist history I could ever possibly imagine. There's just no way. It's just no way.
So what are your thoughts there? What do you think where we are right now in this adoption of genomics into medicine, and what do we need to kind of like keep moving?
So
moving it forward.
You know, when the Genome Project ended, I think those of us, I was at the National Human Genome Research Institute, something that was created by the U.S. Congress to lead the U.S.'s effort in the Human Genome Project. And so some people were whispering, well, maybe the Institute should just go away. So we felt very compelled to explain why we were so necessary. But that just got a lot of us, and when I say us, I mean the genomics community, thinking what was needed beyond the Human Genome Project. Yeah. And of course, the Genome Project was just, you know, a point in time. The end of it was just one finish line, but it was the start of everything, because it was very clear that that was like just table stakes to get us into the genomic revolution. And now we had to capitalize on it. And so, you know, it was very, very clear that we needed better technologies. We needed better understanding about how people varied in their DNA. We needed to understand how the human genome worked. I mean, we still need to understand that. And then, of course, you know, for the medical geneticists and the physician scientists who wanted to pursue it, which I feel I certainly represent, we had to think about how to start to use genomic capabilities to understand human disease, and then to begin to think about how to use genomic information to improve the practice of medicine. So I feel like since the end of the Human Genome Project, you know, we've just been going higher and higher, getting better and better tools, cheaper and cheaper sequencing, better knowledge bases, better databases, better computational tools, better understanding how the human genome works. And just, you know, maybe a decade or so ago, we just started to see over the mountain and started to see what was possible in this new landscape of genomic medicine. And it's here. We're starting to see it. I temper it by pointing out these are just the earliest examples. You know, it's by no means mainstream yet, although maybe in a couple little niches it's getting to be mainstream. But the view is breathtaking, and it's once again this feeling of this is really going to change humankind. This has this incredible opportunity, and it's not going to be easy, and there's lots of obstacles, and we could think of lots of reasons why it won't be so simple, but it's already here. We're already starting to see this change people's lives and improve clinical outcomes. And yet I feel like we still have so much more to do.
Can you tell us a little bit about that experience and what it was for you to go from the public sector to the private sector now?
I was raised in academia, getting my MD, PhD. I never really envisioned a career in the government. I found myself in the government 4 years into the Human Genome Project, and then I was there for over 3 decades. But an opportunity, emerged to come to Illumina, and now I'm in the third major part of this wonderful ecosystem. There's academia, the government, and the private sector, and now I'll have touched all 3 of them. But it's exciting, and in some ways it feels very different. In some ways it feels absolutely the same. I mean, one thing that I've come to realize is the commonality between NHGRI, the National Human Genome Research Institute, and the community of scientists that it represents, and then Illumina is what I would call inspirational audacity. Everything they do is just so inspirational, and but they do it with just crazy audacity. Starting with the idea we were going to do the Human Genome Project. So, a lot of the operational aspects are different, obviously, but at the core and the culture and the vibe, it's very similar between NHGRI and Illumina.
Right, we're all scientists, right? That I think was awesome.
And
we all
laser
try to work
focused
together
on overachieving and have a spirit of collaboration, but a spirit of, absolutely anything's possible.
Yeah, I feel the same, and I don't. So because we breathe it every day, if we talk about genomics every day, we make tools every day. We're in a privileged position, I think. I wish that everybody had access to genomics when they need it. And I feel that we're not quite there. Even in countries as advanced as the US or in Europe or in many other countries, we're still not there. What do you think is missing? Is it education? Are the tools not quite ready? As the Chief Medical Officer, Eric, what keeps you up at night?
So it's not the scientific challenges so much anymore. Actually, now more than ever, now that I've really see what's going on here in technology development and capabilities, what really keeps me up at night is not our ability to get genomic information that will help patients. It's implementing that, and not just here in the US, around the world. Just because you can get that information, getting that operationalized to change the management of a patient is still daunting to most healthcare professionals. And there's a lot of reasons for it. And, and most of them now, I'm going to pivot into all these sociological and societal challenges. I mean, it starts with how we are educating medical professionals, not even just clinicians and physicians, nurses, physician assistants, pharmacists. This is, and we are victims of our own success here. If we hadn't made so much progress, well, then the education system could catch up. But this happens so fast and furious that there's so many things clinicians have to deal with every day in whatever country they're in. They're just swimming upstream all the time. And now we're lobbing something over at them that they're not super familiar with, and handing them a complete blueprint of their patient. That's pretty intimidating. And so there's that, so some of this is, and then I go around, and what keeps me up at night, I've gone to some countries that I've never visited or talked to health ministers or talked to practicing physicians in some other countries, and they are, they just think about things a little differently and what the priorities are, and they have a different slant. And then all of a sudden, being the Illumina Chief Medical Officer, like, oh my goodness, I mean, we've got to be thinking about how we're going to facilitate genomic medicine in hundreds of countries, each with a different story. Because the science is common across all that. The difference is the implementation, the on the ground, in the patient's room, at the patient's bedside implementation. And there's just so many nuanced barriers it's what keeps me up at night. And what keeps me up at night is, thinking about fairness and equity and making sure people benefit in a way. We don't want to exacerbate disparities. We're at great risk for doing it.
100%.
And changing healthcare, is never simple, and it's always complicated. Paying for healthcare and lots of philosophical things of, where do you put your resources and what's the priority? And I've spent some time already traveling internationally and thinking with my chief medical officer hat for a global company. Different countries really do view healthcare priorities in different ways.
Yep.
And we're trying to integrate genomics into very different, culturally different, context different healthcare systems. And it's probably when you've seen one country do it, you've seen one country do it, and it's going to be different for every other country. So I think we have to be prepared for both tackling the scientific challenges and the medical challenges, but also the societal challenges. And I think it's important to make sure we're aware of it, because I don't think any of us should say, we're only going to worry about the scientific ones and then we're going to leave the other ones. So, no, we have to be at the table. Now, maybe I may not be the world expert in health economics or in some other aspects of cultural aspects of healthcare, but I want to at least be there to inform and to explain and to strategize. I think you and I should be at the table, and just as much as those experts should be at our table talking to us too, to figure out what's coming and what are the challenges that need to be accounted for when you're implementing something new in a healthcare system.
I sometimes think the cases where genomics was adopted the fastest, right? So non-invasive prenatal testing was one of the easiest ones to see, and it was mostly consumer driven, right? So moms were like, I don't want to have a test that can put my baby at risk. I want to have another thing first. Do you think that is going to happen in general in like genomics adoption, where we're going to be having people that are more educated in genomics and what it can bring to them, and then talk to their doctor, a more two-way conversation? Or will it come from the top?
I think it's going to come from both. And I think it's going to come in all different ways, probably in different countries in different ways. I mean, even the example you give of non-invasive genetic testing, that came about, on the with momentum of more invasive methods for genetically screening unborn children, as my wife and I did for our two kids, and lots of people did. But that involved something invasive, and now so that was well established for decades. Yeah. And then you had something that came in, was non-invasive and not dangerous and much less expensive. And at least in the United States and other countries, the insurance companies jumped in and said, "Oh yeah, for sure, because less expensive, less dangerous." So that also drove it. So I think every one of these is going to have a different storyline. I mean, I think cancer is going to have a different storyline. Rare genetics is a different storyline. So I think we're just going to see different things. I mean, even the way, these earliest examples that we've seen, that was absolutely not top down, because I can certainly tell you that at the vantage point I had as a director of a funding agency that was trying to make genomic medicine a reality, we weren't sitting there going, we want to here, and here. Rather, it almost was idiosyncratic. It just sort of popped up. Yeah. We tried to stimulate in multiple areas. We just stood back to see where did the areas pop up, and it was not in our control where you were going to see the greatest progress. And it's in some ways it happened in ways we couldn't have predicted, and I think that will continue to some extent. And guess what? Of course, technology is going to drive this, and whatever if there's technological innovations in certain ways that will facilitate certain medical applications, those will happen faster because of the technical innovations.
So I think for years we drove at Illumina, right? I've been here 22 years, so we couldn't sequence 5x when I started, and now we can sequence genomes for less than $200. But when you see how the field has evolved and what we put our energy into, it was mostly lowering the price of what a genome was so that it could be accessible for everybody. Do you really think that is the main barrier right now for adoption in the tools that we have, or what are the things? Because genomics is prevalent, but not prevalent enough. We want it in more doctors' hands. We want it reaching more patients so that it's clear what the diagnosis is, so that doctors can make more informed decisions. But it feels like it's not an even race, right? So what is limiting it, and what can we do to make it more available?
I don't think it's the cost of generating the data. I think we've made remarkable progress. That's not what's limiting. I mean, I want to start with the scientific and then move into the sociological. I mean, scientifically, There's still a lot of the human genome we don't understand. There's still a lot about genomic variation that we don't understand how that influences genome function. There's a lot about human disease that is not going to be accounted for by the parts of the genome that we know how to interpret. And then there's a lot of parts of human disease that have nothing to do with genomics, but they have an interplay with genomics. And so the medical and scientific complexity is still probably the greatest challenge. But then once you get beyond that, then, physicians, you don't want to change things, payers don't want to pay for things, patients maybe, need to be educated or maybe not interested or concerned, and maybe don't have the time to explain to them. So there's, you just start going through a whole host of things. And then it's something that, I know we are both concerned about is we also want to make sure that the patients that do benefit the most aren't the wealthy ones and the ones in the best situation or live in the best country for genomics. I mean, we want to see this available to all. And, that brings on a whole set of other challenges.
So when you think about genomics or oncology in particular, cancer is a disease of the genome, right? Mm-hmm. So it feels natural that will be the first transition or broadly adoption of genomics into that field. What are your thoughts there? What do you think needs to happen to actually move it faster? Like, why cannot everybody that is diagnosed with cancer get a test that tells them what the mutations on their tumor are?
As you well know, cancer is not a single disease. So every type of cancer almost has this, and even there's subtypes, and there's so many different storylines. And then there's so many different ways of thinking about it. I mean, and because of all the differences, the different cancers behave differently, ways of monitoring, either or detecting it early or monitoring it and surveilling it afterwards. But you want to have the different progression and how you have to intervene, when you're going to intervene. There's just so many stories, and we're going to need technological entry points for every one of these things, and maybe slightly different. But again, what I see technologically is having those tools available, but there's still not quite cheap enough. People don't totally know how to use them. But there's a lot of activity going in. There's a lot of studies that I think will really be very helpful. But it ends up not just being a single storyline. It's dozens and dozens of different storylines.
Do you really think that whole genome will be the future of oncology? Whole genome sequencing will be the future of oncology diagnosis and treatment, or?
If I was a betting person, I'd say yes. That coupled with probably some epigenomic profiling, and how that gets deployed, and whether we're looking in blood or cell-free, or there's a whole set of other things to be thinking about how and practical ways we're going to use that.
When I think about public health and what a government decides to, particularly in single-payer systems or in other countries, when we choose what treatment to follow, you look for lots of numbers, right? And we just said each cancer is almost its own little world. So are there things that we have to do with our tools and our information and in the scientific field in general to help push this into more broad adoption? I kind of struggle a little bit to see, I don't know, vaccination from my point of view is a bit easier, right? So you have a vaccine, it works against a virus, you treat a lot of people and it's good. Now cancer or genomics for cancer, each cancer is a little bit different, and finding a drug for your particular cancer may be a little bit more challenging. So it feels like we have to have multiple players working together to actually make this a reality.
You're leaning into the whole therapeutic side of this equation,
yes.
which is certainly incredibly important, incredibly complicated, and something that I certainly have very little expertise in. But in many ways, at least as of now, Illumina, this is not sort of Illumina's sweet spot. But what you are also pointing out is that in the case of something like cancer, that hidden within the genomic profile of each tumor are probably really important clues about what treatments, sometimes chemical treatments, sometimes maybe not chemical, but what's the optimal treatments. And the bigger the repertoire of options, the better poised we may be to eventually figure out what the match is for an individual's tumor and its profile to the treatment options. And wow, that starts to make, my brain explode. And it makes you wonder, do we have enough options or do we need to have more options? And these are all the studies that have to be done and are ongoing.
And do you think that will push us, because it's complex, also to early detection? So finding ways of detecting cancer much earlier so that we can just take it out?
Yeah, well, I mean, there's almost every example is that the earlier you catch anything, whether it's an infection or it's cancer, the earlier, the easier it is to eliminate. So there's no question that the cancer has story after story after story about early detection means better outcomes.
So when we go to the future and the history book of medicine is written, where will genomics play? What will be its character? How will it be written?
So I'm an optimist here, and I'm extremely proud of the field, but I think it's going to be right up there with some of the major innovations we've seen in the history of medicine so far. I mean, some young medical trainees can't believe we could practice medicine before antibiotics or anesthesia. I mean, but we once did. Or before the kind of imaging technologies, whether it be MRIs or ultrasound, but we once did. And those are all things that are just taken for granted, as are electronic medical records are just taken for granted. But there was a day everything was paper written and very inefficient to looking things up, et cetera, et cetera. I think we will look back on how we practice medicine before genome sequencing is routine and then after. And, another way I've been thinking about it lately, maybe because in my new role at Illumina, I do travel a lot for the company. So I'm on airplanes quite a bit. And, I wouldn't, nor would you, get on an airplane today if the mechanic servicing that airplane didn't have the blueprint of that airplane in front of them. You want them to have that blueprint and all of the knowledge of that airplane as they get it ready for you to fly in it. And I could imagine 10, 15 years from now, not now, but 10, 15 years from now, I think we're going to pass a threshold where every child will get their genome sequenced at birth, and as part of their care throughout life, that blueprint will be in front of their physician. And maybe 50 years from now, medical students will look back and say, you mean you once had to practice medicine without having a genome sequence of the patient in front of you? How prehistoric, how barbaric was that? And I honestly believe genomics will be in that same category, that we'll look back and just couldn't believe we could practice medicine without genome sequence data about individual patients, guiding their care, guiding their management, guiding their treatment.
That's awesome to think of a future like that. I heard that you're a Swiftie. We're wearing bracelets here to show our love for genomics.
I was late to the party, but I have become a Swiftie.
How did that happen, and what do you think she should know about genomics?
The honest truth is, the way it kind of sort of happened is I had sort of heard of Taylor Swift, but then our family's very football oriented. Then she came on the NFL scene, and my rest of my family knew all about her, but all of a sudden I hear about this famous singer, dating this football player, and I say, well, what are some of her songs? I wasn't even sure. And then all of a sudden I realized there were a lot of songs I didn't know were hers that I had heard that I loved. And then I started listening to more of them. And then I was all in.
Nice.
Just all in.
Like everybody else.
And then I find out that she was born the year before the Human Genome Project started. And I also thought that was significant.
And then you found out she had cats. Can you tell us a little bit about your cats?
Well, we have many cats, especially now. At the moment, we have 4 cats, including 2 rescued. Oh, they're all rescued, but 2 little kittens. But yes, and then the fact that she likes cats, and I am very supportive of a colleague of mine who's trying to get in touch with her to get a few hairs of her cat and wants to sequence her cat's genome and get her interested in genomics.
That will be cool. Get her to write a song about genomics.
Yes.
I had quite a bit of fun with you a few weeks back when we got an opportunity to take you back to the bench and do a little bit of sequencing with our new TruePath method.
All of a sudden, I was told I had to set up a TruePath experiment, and there was a lot of whispering behind me like, when was the last time you pipetted? And I had to think for a second, and I realized the answer was probably more than 30 years ago. I had not held a pipetman or pipetted of any kind. And but the cameras were rolling and the people were watching, and I take a challenge very easily. So I said, I'm going to go for it. And you provided very patient, kind mentor or tutor, one of the technicians in the lab, and they just told me what to do, and I did it. But the funniest part, I will say, and I've told this story to many people because you guys were interviewing me at the same time.
Yep.
And you're saying, okay, now pick up that screw cap tube and now unscrew it. And I'm talking to them without thinking about it. And I grabbed the tube, and without thinking about it, with two of my fingers, I unscrewed it. Instead of using two hands, I did it with one hand. And I don't know how I remembered to do that. And I wasn't even thinking about it. And it just shows that when you've done that 1,000 times at an earlier stage of your life, it just comes back.
Well, thank you so much, Eric, for this conversation. I thoroughly enjoyed it. I hope our viewers also enjoyed it. It was a wonderful half an hour of us together talking about the past and the future and what genomics will bring to us.
It was a pleasure to join you here today. And I thought it was a lot of fun.
Yeah, me too. Well, thank you, everybody. And I hope you enjoyed the sequence. And I'm really looking forward to seeing what other conversations we can bring to you and how you can join us in it. Thank you.